about, so it was in the 2008 timeframe. So it's almost been 12 years since I graduated. One of the key themes that you'd hear a lot about is that the world was moving towards technology and towards digital transformation, right? That term was just coined. It had just entered the lexicon of modern IT. And the key theme in that was that software no longer just supports the business, but it becomes an integral component that runs the business. And when a Walmart competes with an Amazon, it's more our target. It's not so much my supply chain system versus yours, but my tech versus your tech. And I think with companies like Amazon, we've seen very clearly how a company just interacts with its customers through software. And that software is basically delivered as an online service or an application. It's delivered to all sorts of devices that people use. But also in the back end, companies are using software more and more to increase their operational efficiency. And that includes, if you're in manufacturing or in retail, your value chain, right? It includes your logistics, your operations, your communications. Somebody made a statement to me today, or I was talking to a customer who lives in the upstate New York area, and he lives near the Erie Canal, and he was telling me that the Erie Canal was the internet of the 18th century, right? It transformed the way people worked, where people lived, and how people did business. And I think with COVID, this is a very important topical area at this point, because cloud computing, DevOps, they're very clearly setting up winners versus laggards. Companies that have invested in an online business model, in software as a service, and they've got the best development pipelines are the ones that are succeeding. And you can see that played out very clearly in the stock market at this point. So with that in mind, let's talk about what DevOps is and then go from there. So essentially, all of us are at some point, we have been software developers. And we've been part of software development projects where it's taken us months to basically, get an idea, or maybe a year to take an idea from conception to deployment, right? And furthermore, long feedback cycles that can span months to understand the impact of a certain feature or a certain release. And we're used to, a bunch of bug fixes being a major release, right, so to speak. And deploying applications, monitoring those applications has been a pain as well. What DevOps does is it basically brings development teams and operations teams that are shown in this diagram. The left is the development side, which is source code is built, source code is written, projects are built, tested, and the artifacts are stored in some repository, and then they're deployed to production. So these two aspects of the development cycle and the deployment cycle are siloed in most organizations. But what DevOps tries to do is merges these teams and these cycles into one single pipeline, one single operations team, where engineers are basically working the entire application lifecycle, right from development and test to the deployment to operations. And every individual working on these projects is supposed to have a range of skills that are not limited by a job definition or limited to a single deployment function. So you no longer have the challenge of, hey, the development team has built an application that they've thrown over the wall, and the operations team is now their child. They got to figure out how to deploy it. At the same time, when customers come back with feedback around features that are not working or incremental functionality, the operations team has no idea, but they have to involve the developers. So with that in mind, let's talk about what are the three main capabilities or the main features that DevOps brings, right? So from the perspective of developers and from the perspective of operations people, DevOps enforces standardization. So the cloud is all about standardization, and properly executed cloud projects save cost. And they save cost because they standardize environments. They standardize a whole bunch of code that is written, not just to build the project or to release the business functionality, but also in terms of scripting that's done and maintenance that's done to release the product across multiple clouds. And then also in terms of standardization of strategies that deal with when releases happen, the cadence that they happen, and the rollback that happens. So the first thing that you got to look for in the way I define DevOps is that standardization is going to be enforced, and that has benefits that we'll see in the following slides. The next benefits is that it fixes a fragile process. Those of you who like this space in terms of, you want to understand what the pioneers are doing, right? Netflix is rightly hailed as a pioneer for DevOps because at Netflix, every software developer that joins the company, she or he, on day one, makes a change that makes it all the way into production. So the idea is that for those of us that work in enterprise companies that have a background in the Fortune 5000 enterprise space, not the web scale space. So I'm not talking the FANG companies, right? The Facebooks, the Amazons, the Netflixes, the Google/Alphabets, the Apples, so on and so forth. You'll see that doing a change, a novice developer, novice to the company makes a change on day one of their employment, and that makes it all the way to production. That is largely unheard of because we all operate in a way that is very fragile. We operate in a way where there's a lot of manual handovers, which are anytime you add humans in the process, you get errors, and things are time consuming, right? So we're not really used to having rapid delivery that's done in a highly reliable manner. But so what DevOps tries to do is tries to fix it by enforcing automation and improve collaboration across the whole life cycle. And then Ravi, the third one, the manageability is the big one, right? There's a whole equation of manageability that developers are not aware of. Once you develop an application and you deploy it to production or to a test environment, the operations team that takes over, their job is to, kind of run the trains in New York City subway, right? The reason I use that metaphor is that as long as the trains run in any large metro, nobody cares, right? The teams, the public transit teams that are doing all the complex work of running the subway systems, they don't get kudos every day. But imagine the trains are down, or something happens in the chain where trains are behind or not operational. Oh my God, you hear about it from the press, you hear about it from the customers. So the most important aspect of developing an app is not just the functionality, but how is this going to look in production? How is it going to run? A whole gamut of production issues going to be covered in terms of scaling up infrastructure, up and down, in terms of ensuring that the environment is reliable, so on and so forth. So if you look at where companies are on their DevOps maturity, for most of the Fortune 5000, maybe they're starting out on their DevOps journey, which is probably true. But the web scales, the FANG companies, right? They're the poster child of DevOps, but they're the poster children of DevOps. But there's a whole bunch of other players in the space. They have taken it to the next step. So for those of you who like this space, look for things like chaos engineering. And Netflix has a project called Chaos Monkey, where there's a random process that keeps going around in their production AWS environment, infrastructure, and keeps taking down worker nodes. And what they want to do is get what is called anti-fragile, which is make sure that chaos and the fact that there's going to be cascading failures in the environment, that's going to be a fact of life. But when we develop software applications, we want to be able to factor those in as risks that exist in the real life and in the real world, and to go from there. Ravi, next slide. So what are the top business reasons why anybody wants to enforce and use DevOps, right? The first and the most important one is your customer experience. So this is not a hard thing to kind of think about, right? You have customers that are, so if you're a bank, most banks operate in a bit of a stone age, right? Why do I say that? The banking business model essentially is unchanged from the time it was invented in the 17th century, which is, there is basically a humorous way of referring to it. It's called the 363 industry, right? What that means is you borrow at 3% from the Fed, you lend it 6% to your customers, and you show up at the golf course at 3 p.m., right? By and large, that works for all banks, right? So though banks are some of the most complex IT out there, they essentially lend money, and then they basically, make a cut from, what they borrow from the Fed, and what they lend to customers. And they have captive customers, because most of us, think about it, you have your mortgage company that you've been working with since the time you pretty much got your mortgage. Maybe you've refinanced once or twice. But again, once you've refinanced, you really don't do it typically, in the life of a mortgage. Maybe you're gaming the system, or you're looking for a better rate all the time. But most of us refinance maybe once or twice in the course of a 30-year mortgage. So if you take a bank, for instance, they have no incentive to improve your customer experience. And how can I say that? I can say that because the bank, I have 3 different banks that my wife and I have accounts in. We have 4 different credit cards, companies we do business with. We have 2 different auto loans. And, for college, all of that, it's again, different institutions, right? You should ask yourself the question, if you work for a bank, if you have all this data about a customer that you have, that's been working with you for 15, 20 years, why couldn't you get more of their wallet share? And if you take the fintechs right now, that is what they're after, right? So what the fintechs do compared to the bank is that they are very good at improving your customer experience. They enable you to bank from a mobile device. They enable you to do e-banking, and so on and so forth. But they also take that data to basically offer you more relevant products. So for instance, if you go to Amazon and you buy a product, the next time you log in, Amazon knows, based on who you are, they're able to segment your customer experience and give you, there's one Amazon.com globally, but every individual has their own Amazon.com, because Amazon can suggest products to you. They can promote products to you, so on and so forth. So again, like Netflix, they can show you what people watched based on your interests, right? So for instance, if you log into my Netflix, it understands that, I like World War II kind of, documentaries. I'm not so much of a watcher for entertainment as it is to get my knowledge, right? So they're able to push out content that I like, that results in more videos, that results in a more sticky experience for the customer, right? So the first instance and the first reason why you have to use DevOps is to improve your customer experience, and then to ultimately increase the revenue per customer that you're generating, increase the net promoter score that a customer has, so on and so forth. So moving to the next point is, you want to innovate at the speed of business. So a very famous quote on Wall Street, IT, right? And that's my backyard, typically New York City, is that it takes 40 days to basically launch an environment once you decide you have a project in hand, right? So even at a bank like JP Morgan, which is probably the leading institution globally, it's a 40-day cycle to basically get your infrastructure stood up, so developers can deploy an application or work in an idea. But if you look at what people do, why Amazon, and Azure have grown so much, it's that people can take credit card and go to these cloud providers or hyperscalers and basically get access to their complete environment and start developing an application, right? So innovation matters, but it matters the speed at which you do it with. And this is not just to launch projects or at the start of big initiatives, but also in the course of application deployment. Every time the business owner comes back to you with a requirement and says that they need a certain app to behave different, or they need a different business rule to be put in, or for some business reason, say for instance, from October to December, you want to be able to relax some of the criteria that you use to grant business loans, because maybe that's the time where a lot of people earn their bonuses, right? People have more money than what their credit score shows or the ability shows. So that kind of innovation cannot happen if your applications typically take weeks or months to basically, to deploy, right? And the application is the point of interaction that a customer has. And in industries like retail, this shows up more and more with things like real-time couponing. Based on what you've purchased, the retailer wants to show your coupon that has the promotion for a certain type of fashion. You get 30% off if you want to go buy something, right? So that innovation is something that is only possible if your applications are able to enable it. And that's one key reason to use DevOps. So support scale, that's the third one, right? Typically, if you look at digital every large Fortune 500 company, right, has a digital operation. And the way they do digital is they basically buy, more fashionable space somewhere down. And if you're a company that works in the Boston area, then in Boston is where you do it. Or if you're a company that's in the Northeast, New York City is where you do it. If you're a company in the West Coast, San Francisco is where you do it. If you're a company in the Texas, in the North Texas area, maybe Dallas, downtown Dallas is where you do it, because you want to attract younger developers typically, right? And I use that term with respect, not to suggest that older developers are kind of immune to DevOps, but the idea is that you want to have younger people that would typically be hired by your Googles, your Facebooks, and Netflixes to work for your bank, right? Or to work for your manufacturing company. But again, when you start inserting these things and you start letting them choose the tools that they need to choose to make things work, scale becomes a problem very quickly, because you've taken the innovation that they have created and you want to basically feed it back into your larger corporate cycle, your established teams. That kind of scale can only happen when you have an automated process, right? Automated process across development, across deployment, across operations. So that means multiple teams supporting multiple tenants within the same infrastructure, whether it's public cloud, private cloud, or virtualized infrastructure, and then independent code bases, right? What that means is a lot of DevOps projects typically use microservices. And what the microservice architecture makes possible is that it decouples or simplifies large complex systems into simple independent code bases. And the idea is that you take an application, you break it down into many individual components based on the function that is performed, the business function. Each function is called a service, and each service operates independently of the peer services and even the application as a whole. So what that means is the overhead of updating the application is reduced drastically, right? In terms of, you say have a company that is, that has 4 different geographical areas, of operation. And what you want to do then is each of those teams has their own code bases that they work with. They choose their own databases they want to work in. They choose their own application frameworks they want to use within reason, right? And this is the reason why I say that. It's called Conway's Law, if you want to look it up. But the idea is that with DevOps, you're able to then basically have the standardization of functionality across all of those teams. And then you also avoid what many companies spawn when they basically have geographically distributed far-flung teams, Conway's Law, right? An organization develops software based on the geographical boundaries, right? But the idea is that with DevOps, with microservices, within reason, within architectural stack rationality, you're able to support the scale that you need, and all of them speak one common language as well. So DevOps is that methodology that IT has known to make multiple teams work in multi-tenant deployment fashion while operating on independent code bases. Ravi, next one. So again, agile deployments, right? What do I mean by agile deployments? For those of you who are in this whole area that deals with deployment automation, you've used tools like Puppet, Chef, maybe you're using an Ansible or a Terraform right now. All of these tools do different things. I encourage you to check out something called service meshes, right? What a service mesh does is manages deployment or controls how deployments are done in terms of right from the time the app is developed. For those of you who have been through the whole enterprise Java movement, right? I was one of those, right? In 98, when I graduated out of college, I got right into deployment first in India in a company that did software deployment, server automation, all that good stuff for Unix-based systems. And then very quickly, I got into the whole Java J2E world. And in Java J2E, the thing you do, and this is probably true of, 70% of shops that, right, even now, that build with Java technology, is that, you basically build very heavyweight application artifacts called enterprise archives, EAR files, and web archives, WAR files, or maybe even jar files, right? Java archives. And these are just compiled libraries. But the problem that you have is When you deploy these applications into production grid environments where you've got real active live traffic that your apps are taking, you basically have to do a lot of kung fu when it comes to deploying the app. So you got version 1 of the app running that's got a community of users, maybe millions, right? Depending on how successful you are. Or maybe it's a mortgage app. Or, I've done work with the federal, housing banking system. And they basically used to process tens of hundreds of millions of dollars, right? In a given day in Java apps. But the idea is that you got V1 working that is serving all customers well. And you've built this V2. But your problem now is, how do you know that V2 is solid? And how do you know that it's not broken in any given way without taking V1 out of production? So we do all these magical things called side-by-side deployments, which were very, very clunky to do. They were extremely hard to set up from an operational standpoint. And you oftentimes did not know or figure out errors till you're much further along in the process. And as you move along the cycle of DevOps, as shown in the previous picture, risk increases from left to right. The business risk increases. Every time you have failure, as you grow closer to customers, you're going to deal with a lot of operational headaches and lost revenue, ultimately, right? It's all about revenue, customer revenue. So service meshes in DevOps basically let you do what are called deployments where you're basically injecting errors into the deployment, right? Blue-green deployments is a term, right? Which means that you deploy into a blue mode, but you only turn into a green mode based on your error rate that you're seeing. But it's all automated with DevOps so that you don't have to basically go through all of these painful manual deployments. You basically have the framework that handles deployment. You just set it via policy, and it handles the deployment to make sure that if a certain V2 of a deployment has got errors, it rolls that back and makes V1 available till those errors are fixed. So DevOps comes in to the industry with a whole bunch of industry work done around Kubernetes, service mesh technology, around distributed monitoring like Prometheus, so on and so forth. So that's one key reason to use it from a business standpoint is you can go to more agile, more cleaner deployments with built-in error checking and handling. So finally, number 5, improve employee satisfaction, right? What do I mean by that? A key challenge a lot of customers have right now is attracting and holding on to their high performers. And if those high performers are going to be hired by the hyperscalers or by the Apples of the world, then you're not going to get access to that kind of talent. DevOps has been consistently shown to improve the satisfaction that that people have when they build applications, because they can see their work get to production much quicker. They can see it impacting customer experience. They can see it leading to digital transformation or contributing to the rapid pace of digital transformation. So with that in mind, when you go to DevOps model, you are going to have maybe some initial bumps in the process, but it's mostly a well thought out, scientific, rational, and well-articulated discipline. So you go to a GSI like a Tata or like an Accenture or Infosys, or you go to a PricewaterhouseCoopers or a Ernst & Young, everybody speaks a DevOps language. So you're able to actually get the right resources for your projects that contribute to an increase in your business bottom line, but also have more satisfied and more involved employee stakeholders. So with that in mind, let's go to the next slide. So what is DevOps in 2021, right? And I'll take a very, very developer and operations focused view in these next 2 slides, because that's kind of the 2 main people that are impacted. And let's do a 201 or a 301 into what this means for developers. So for developers, the first thing a DevOps process gives you self-service. What that means is you get a public cloud experience in your private infrastructure. So what that means is no more going to ServiceNow, opening up a ticket or whatever system you have of record, opening up a ticket, requisitioning IT for capacity, and then twiddling your thumbs for 3 months or 4 months till that capacity shows up, right? When you have a true DevOps practice, a true DevOps foundational infrastructure pattern, so on and so forth, your developers are able to go in and IT gets out of the way, infrastructure gets out of the way. They're able to open up a ticket. They're able to get the environment that they want, that they need. So for instance, if you are an N-tier application development shop, which a lot of us are, you basically have a web app, a web server farm, your application servers, your database servers, and with a whole complex set of interconnects from a networking and a firewall standpoint. No more 40 or 50 days to have that be made available by your operations teams. All you do is go to a portal, enter what you need, pick the t-shirt sizes for the servers you need, enter in more information such as what kind of software do you want installed on those servers, click a button, and that's all made available. And it's right there in minutes. So that's the first thing for developers, is complete self-service, end-to-end, from environment creation to destruction. Number two, your DevOps infrastructure should offer you a way to onboard and deploy apps. What that means is once you've built in the infrastructure, the foundational infrastructure for it, you can pick the kind of app you want deployed on it with a single click of a button, not just deploy the infra, but also deploy the app. And deploy the app that has whatever dependencies it needs, right? You want a certain kind of Tomcat, as well as maybe a Spring Boot microservices framework, and then maybe PostgreSQL with MongoDB. All of those are available. Again, a simple button click or an API call as well. So pipelines are managed as code, right? The code then becomes a contract between the developer teams and the operations teams. There is something called GitOps that you should all take a look at. What GitOps does is it's a way of developing software or continuously developing and deploying CI and CD. But all of the application configuration, all of the application delivery semantics are all managed using Git. And Git becomes a single source of truth for all your declarative infrastructure and declarative applications. And there are software agents that are then deployed using things like Kubernetes, which constantly monitor the difference or divergence between what's in Git versus what's running in a cluster. And if there's a difference, the application or the platform automatically goes in, reconciles or updates or rolls back the cluster depending on the case. And then what that manages is that Git becomes the center of your delivery pipelines. Developers use your familiar tools that make pull requests, and these requests simply accelerate and make more simple all of the developer tasks that are typically done. So again, the managed pipelines as code basically is a way of using GitOps or other cloud native technologies, and all your best practices that span development, that span management, monitoring, all become stored in Git, and that becomes your single source of truth. Again, I use tools that I'm familiar with, but it's not to say that only Git is to be used. You can use Git or a variant of Git, but typically that's the best practice that I see used more and more. Ravi, next slide or next point. Yep. So again, any software customization that you want to do becomes easy with simple extensions. So what that means is, for instance, if you're deploying now to VMware, or you're deploying to bare metal, or you're deploying to Amazon, to deploy to Azure becomes very easy using an adapter or whatever have you with these tools. So again, the open source community makes all of these available and makes these tools available so that you can go ahead, deploy with a simple extension or a plugin or an adapter. So with that in mind, the other thing is visibility and diagnostics, right? Developers are also share complete visibility into how the app is working. So no more the whole operations and developer debugging, 3 a.m. debugging cycles where the developer is called by the operations team and they're looking at complex log files. Developer says it worked well on my machine. I don't know why it's not working on the environment, the production environment. Maybe there's a divergence there, or maybe there's a setting somewhere that is out of whack. What it means is that with that one single control loop that is set up, you've got complete visibility and diagnostics across the value chain, right from the time software is written to the time it's deployed, and then the day 2 operations, right? Which is, how do I diagnose issues? How do I upgrade? What are the common issues I see? What's the baseline functionality, so on and so forth. And again, you want to have a declarative specification for all the common strategies that deal with what kind of applications you're running, 3-tier, 2-tier, 1-tier, so on and so forth. So for operations team, what does this do? Number one, it provides them single-click deployments. They're able to deploy an application that's been developed right into a production-grade cluster with complex networking, complex storage dependencies, right with a single click. And then operations can basically provide developers feedback on what the best practices are to deploy a certain application, right? What the minimal number of servers will be. How beefy do these servers have to be? And what kind of metrics are going to have to be gleaned out of these environments, and so on and so forth. And then no more manual judgments, right? Day in and day out. But again, where you need the manual judgment for key applications, operations team has complete, they have the complete control over what kind of applications promoted. I used the example of V1 to V2. All of these can be tied in using tools like Spinnaker or JenkinsX, where manual judgments are used, where there is a lot of functionality or security implications that are being pushed out. And I'll talk about that in terms of how to categorize that, right? How to know if your DevOps is successful. But the idea is when you have beyond a certain set of use case stories, that's when you probably want to use a manual judgment and not have everything be automated. Because more use case stories means more functionality, means more customer satisfaction impact and revenue impacts. And then the deployment strategies then become risk-based, right? I use the word, blue-green deployments, right? But service meshes, again, I go to service mesh because, service meshes provide what are called blue-green deployments, right? But the idea is that you want to be able to deploy in a way where you've got what are called canary deployments and blue-green deployments. But the idea is very simple, right? The number one problem that you have, the number one risk you have in a deployment is downtime. So you don't want to have downtime when environments are live, when you're basically serving live traffic with your production environment, but then you prepare a new version of your software and the final stages of testing are still happening. You want to be able to deploy and fully test the software to green. And with the DevOps pipeline and with the properly state-of-art DevOps implementation, operations can manage and mitigate and reduce the risk that is involved with doing complex deployments. Again, rollbacks, right? You've deployed, but then you want to roll back. You maybe want to roll back servers because you've stopped taking peak traffic. You don't want to have so many servers provisioned. But at the same time, if a certain version of a software application, incremental version, has got errors that are more than 0.2%, again, I just pulled a guesstimate out. You want to have the rollback be done in both of these cases and be done automatically. In the past, if you worked in an operations environment, this was a major risk. You could lose your job over a badly done rollback. But with DevOps, what happens now is that all of the rollback happens quick. It happens seamlessly. V2 is pulled back up, and then V1 is promoted back in, right? And all of that happens. Customers that are being served by V2 are migrated over to V1. Again, with two caveats in terms of what they've done and what kind of transactions have or have not committed. But the idea is that generally it's a much more smoother option than in the past. Chaos engineering as well, right? I mentioned the fact that Netflix has got these frameworks called Chaos Monkey, so on and so forth. What DevOps lets you do is it lets you adopt the anti-fragile movement. What that means is, tools that enable your SREs, which are site reliability engineers, they're basically being able to incorporate chaos into their testing, which is what if they had a cascading failure of the environment? What if a certain data center went down? How well does our disaster recovery work? How well does the application adapt to that sort of a DR environment? And what are the risk impacts? Can they be documented? Can they be shared? And can these be mitigated? So chaos engineering is then welcomed as a discipline rather than having it be a risk that can cause, that is remote. But then when it happens, it can basically bring down your data centers, bring down your applications, and lead you to, losing your customers, right? You want to avoid that. So again, with all this preamble out of the way, what are the main metrics of DevOps? And I think I've got maybe 8 more minutes to go. And then Ravi has to speak as well. So I'll go through this a little more quickly. So how do you track what are the best practices, how well your DevOps has been, right? There's a spectrum of DevOps impacts. And how do you get these to be better? Number one, frequency of deployment. This metric tracks how often can you do deployments leveraging your existing CI/CD pipeline, and how granular can you get in your deployments. So the idea is that obviously every week you want to do more high frequency deployments, but maybe do more smaller granular deployments, which is what the second metric is, which is change effectiveness per deployment, right? How much business functionality is getting deployed, how many bug fixes are getting deployed, and how many stories are getting deployed, and how many days worth of development is getting deployed, and how do you basically increase this or decrease this? So if you're doing more frequent deployments, the change can come down per deployment, the risk can come down per deployment, and how well can you manage that? So as your DevOps grows in maturity, you should be able to basically decrease the change effectiveness per deployment. This is where the operations team comes in first.
Vamsi, we are losing your audio. You are breaking up. Vamsi, can you hear me? You may be on an unreliable audio connection, so we're hearing part of what you're saying. I think it may help for you to dial in, switch to the phone. And maybe, Vamsi, while you're switching your audio connection to the phone, then I could just discuss some questions. So some questions that have come in, how does this tie into, how do we tie it into the Agile Value Delivery? There's another question. Can we explore change effectiveness per deployment? So let me talk about what I have more comfort around or experience around, which is the tie-in to Agile. While we are waiting for Vamsi to get back with his phone audio connection. So in my mind, maybe let me add should display the other metrics, so then we could have a conversation. As you look at these metrics, what thoughts do you folks have about how and where we might integrate these metrics into Agile software delivery? And if I was to pick a specific framework, I would say Scrum. So if you have any ideas in terms of what has worked well for you, I'd love to get your reactions on your chat panel. How would you integrate these into Agile Value Delivery with Scrum?
Hey, Ravi, I just rejoined.
Okay. Perfect.
Yeah, I'm back. Can you hear me?
Yes, we can hear you. So Vamsi, I had just asked, there are a couple of questions. One was, where do you integrate Agile software delivery, or how do you integrate these ideas into Agile software delivery? And I said that we will talk about it in, I think, a couple of slides. And the other question that had come in was, can you elaborate on change effectiveness? So I'd given the attendees a question about, while we are waiting for you, I'd given the attendees a question, what ideas do they have about how we integrate these metrics into Agile software delivery? Let me just share a couple of thoughts, and then Vamsi, I'll give control back to you to elaborate on these metrics. In my mind, as we look at these metrics, one simple place where you can plug these ideas into Scrum is your definition of done. So a lot of these are non-functional requirements. So where these are non-functional requirements, we could say that no matter what product backlog item or user story you may be working on, every single PBI has to meet the application definition or the increment definition of done, which means mean time to recover cannot go below X seconds, average, availability, application availability cannot go lower than 99.99% and so on. So that could be one place where you could add, you could integrate these ideas. And I have a few more, but I'll pause until a couple of slides. So Vamsi, back to you. I believe where we lost your audio was you were telling us about change effectiveness per deployment. If you could elaborate just a little bit more about what is the definition. So change effectiveness per deployment means blah.
Sure. It just means how much business functionality are you getting deployed per deployment. So it typically is the amount of business functionality. So you could basically track it in two different ways, right? User stories is one common way. The other is number of days worth of deployment activity. But if you have minor releases or bug releases or errata releases, it's also the amount of bug fixes and their business impact. So I think for every organization that uses DevOps, that metric is going to look different. But the idea is for a more mature DevOps process, change effectiveness per deployment should reduce as you increase the frequency of deployment. So these metrics are in some degree interconnected, right, if you will. But the idea is that you do smaller releases in terms of business functionality, your risk is lesser that, instead of doing a big bang release, if that makes sense.
Okay. Vamsi, you said we should reduce change effectiveness. So I think I misunderstood. So I was interpreting change effectiveness to mean that if I make, let's say, 10 deployments to production, if I make 10 changes to production, let's say in a week, then I was interpreting change effectiveness to mean how many of these 10 changes stick and achieve the desired outcome, as opposed to I made 10 and I had to roll back 2 because it created undesirable impacts. But it sounds to me that is not the correct interpretation.
Yeah, exactly. I think maybe change effectiveness is not the right word. I should maybe call it deployment size or So the idea is
batch size, maybe batch size or the change. Yeah, you're right. The magnitude, the size of this. Yeah. Okay, got it.
Yep. And so I've seen different companies do it in different ways. Enterprises do different ways. So you can track your stories, you can track your feature requests, you can track your bug fixes. And depending on how large an organization or a team defines their own individual work items, those counts can vary, right? And I've seen some companies do number of story points or days worth of development work as well. So, yeah.
Got it, Vamsi. That helps. Okay, please go ahead.
So just to go through the last few quickly, lead time is another important one, right? This is kind of where the operations team kind of gets involved in the process. But here you want to measure the amount of time needed to do an entire deployment. So for major releases that you might be doing or where you're relaying the infrastructure, this includes everything from provisioning the infrastructure, the service, the operating system, if you're using Kubernetes, the workers, the master nodes, and any other dependencies that are needed for the application to basically get in. And but for smaller releases, it can be the amount of time it takes to deploy a work item once it's been cleared to go into production. So that is a way of cutting the smaller it is, that means that you've been able to achieve a higher degree of automation. But again, you want to measure it organization-wide and so on and so forth. Last couple customer tickets, right? I mean, the goal of all of this magic that we're doing at Kung Fu is to release apps that delight customers. So what you want to do here is whatever app you're developing and delivering using the pipeline, does the velocity of the delivery, the quality of the delivery, the performance of the delivery, and the user experience ensure that the tickets that are being opened are dropping consistently over time. And this is a key metric. And I can't stress how important it is for management and executive teams when they try to understand how effective their infrastructure teams and developers are being in solving their customer issues. This is a key metric, right? The other is customer SLAs, right? So I want to categorize this by saying, quantify this by saying that of all tickets raised for the last X number of days, what's been the response time? What's been the fixed time? How has the availability of the system been over the last X days? What are the error rates per deployment? And how do they affect the SLA? How many of these errors are bugs in the app core versus performance issues? And what are things like mean time to failure between deployments that are part of the metric, right? And then finally, the mean time to recovery. So downtime, is a fact of life, but more and more DevOps architectures use self-healing frameworks like Kubernetes. So MTTR is basically a way of understanding how much time do I need to recover from failures, and the lower this is, the better it is, because that means higher availability. So Ravi, yeah, go ahead.
Yeah, so Vamsi, I'd love to get your thoughts. Maybe if you can recommend one most frequently used tool that you would recommend people look into after watching this webinar as a source of truth, as a source to capture and visualize each of these. So
I can recommend two, Ravi, if that's fair. The first, on the developer side, maybe Git and Git-based repos. So things like Bitbucket, code commit, so on and so forth, whatever flavor of Git you're using, or GitHub, whatever have you. There are a bunch of metrics that Git exposes. So these are things like lead time. These are things like number of branches that are open, so on and so forth. And also throughput metrics, which help you assess the length of your development cycle, right? So how quickly are changes getting from the time they've been committed in version control, deployed in front of users? Deployment lead time can sometimes be measured there. So that is one I would recommend. And from the operations team size, I would recommend Jenkins X or Spinnaker, depending on what you use for your CD. And these tools like Spinnaker, which came out of, I think it was Netflix, basically exposes a whole ton of metrics in terms of, a number of deployments you've got. You can sort them by tag. It can show you the counters on, how many activities have occurred within a given period of time, how many failures have happened, how many calls to the infrastructure were successful versus failures, so on and so forth. So I think those are the two tools that I would probably recommend people look at, and they're both open source and free to download and use.
Got it. Thank you. Did you say Jenkins X and Spinnaker?
Yeah, they both compete in the CD space, but Jenkins X, Jenkins X is the cloud-based counterpart of the beloved Jenkins CI platform and CD platform as well. And what it lets you do is it's more cloud native compared to using standard Jenkins. So if you're using Jenkins for Kubernetes, you'll see that developers have to write a lot of glue code to enable Jenkins to understand, pods and rollbacks and so on and so forth. But Jenkins X is basically automated CI/CD for cloud native apps.
Very good. All right, let's spend a little bit of time where I can add my thoughts to complement what Vamsi has shared. So let's talk about where Agile fits in. So I'll go line by line. Frequency of deployment. One of our clients, a fintech client, we have started creating some policies that guide decisions that teams make. For instance, one of the policies is based on managing WIP limits. So if you don't reduce the batch size, as Vamsi was saying, the challenge we faced in our client is sometimes you can go 6 months before you deploy. And when you have 6 months of inventory, where you had 10 developers working for 6 months, that's like 60 person months of development. And you try to clean up 6 months of dishes, dirty dishes in your sink. That is a lot of dishwashing. So we face challenges doing that. And then you have integration issues. So one way we have integrated frequency of deployment inside of our Agile delivery process is we've said, we put some speed bumps to say, what we prefer is that every sprint you go to production. So don't carry more than 1 sprint's worth of inventory. Now you may choose to go dark to production, and that's okay. But we recommend the CTO says that I strongly recommend, I prefer that you don't, I prefer that you would go to production every sprint. However, if you go more than 2 sprints you have more than 2 sprints of inventory, it's no longer a speed bump. It's a hard stop, which means you have to meet with the CTO and the head of your business department to explain to us why it makes more sense for our organization to allow the accumulation of inventory. So in policies on inventory limits have a correlation with frequency of deployment. So that's one way to integrate with Agile. You make your policies explicit. It's kind of like a Kanban, Kanban idea as well, integrating Kanban with Scrum. Change size per deployment. So minimizing batch size. Change size is directly proportional, or shall I say, inversely proportional to your frequency. So the more frequently you deploy, as Vamsi was saying, the more granular will be your change size, and therefore the more granular will be your risk exposure. So our policies have impacted both number 1 and 2. Lead time needed to deploy. We have also got policies for cycle time. So how many calendar days does it take for an item, a sprint ready item, to go to production? So if the CTO says, I would prefer a 5 calendar day cycle time, but I will not accept anything longer than 10 calendar days. One of the things that 2 of our Scrum Masters, Mike and Adrian, in fact, Mike will be speaking at our meetup in the next event. One of the things that they did was they started color coding using Azure DevOps. When an item is reaching the 3-day mark, the card goes yellow. And when the item exceeds 5 days, the item goes red. So what we did was, when you are in the daily Scrum, you are using visual information radiators to alert you when you are at risk of violating that policy. So all hands on deck can go and attack that card or that PBI to reduce the lead time need to deploy. Or rather to reduce the cycle time. And if it turns out that the reason that cards are taking long to go to production because ops is slowing things down, then it creates a transparency and it creates that pressure on ops and the whole ecosystem to improve that process, right? Number of customer tickets, again, we can use information radiators and we can educate the developers to say, guys, the service level agreements we have signed with our customers means that if it's a Feb 1, you've got to have a workaround in like 60 minutes. You've got to respond to the customer maybe in 30 minutes. You've got to have a workaround in 60 minutes. You've got to have a permanent fix in, let's say, 24 hours, right? If you educate your customers and you create information radiators where at the daily Scrum and more often if needed, everybody can see those blaring red lights, then the whole team can self-organize and swing into action. So this is probably more about building in dashboards and educating the customers, educating the team about the SLAs. And mean time to recover, this can be in the definition of done. So whenever anybody is writing any code, they realize that it is unacceptable to compromise on the definition of done. You cannot compromise on elements like mean time to recover. So those are some ideas about integrating with Agile Value Delivery. Vamsi, is there anything else you'd like to add in terms of marrying these 2 frameworks, Agile and DevOps?
Yeah, so I think there is a certain amount of synergy, right? Because DevOps is all about constant testing, constant delivery, and then Agile is incorporating a lot of the these constant changes or into the overall flow. No, I think it complements Agile, right, in a big way. And if you want to deliver Agile, probably DevOps is the best way to do it. And the only thing I'll add is DevOps is CI plus CD. You don't need both to get started, right? Even if you have CI and you start in terms of taking some critical strategic projects and using Agile and incorporating Agile into your CI process, then over a period of time, you can start incorporating continuous delivery as well, because that tends to be typically a little more hard to bring in because it involves the more dimensions in the operations organization too. But the idea is that just doing CI is more automation, more builds, more testing, so on and so forth, and automating everything, right? So,
very good.
So these are some references that I came up with. So to learn more about the DevOps model itself, the Phoenix project obviously is the Bible, and I recommend everyone read it. But I have a blog as well. Again, it's a shameless plug for my blog. And then Atlassian has got obviously tools with Jira, where Jira can also expose a lot of these metrics with its integration with Bitbucket. But yeah, Ravi, anything to add to this?
No, Vamsi, and I also added on the chat panel to all attendees that they could look up service meshes and blue-green deployment, and then GitOps, JenkinsX, and Spinnaker, in addition to the references you've mentioned here.
Perfect.
All right. Okay. So quick recap and maybe last closing thoughts, and then we are over our time. So we'll have to wrap up and take any questions offline via LinkedIn, or you guys can contact me through SmoothApp. So Vamsi, maybe closing thoughts to tie it all up.
No, so basically the 6 key metrics that exist or that help guide you. I'm sure there are more, but I think these are the top 6 that come to mind based on years of working with Fortune 500 companies and web scale shops. How frequently can you do deployments? What is the change size per deployment? Or what is the lead time needed to deploy? How many customer tickets? How's that trending? Are you able to keep the SLAs that you have with your customers? What is the mean time to recovery, so on and so forth? And the reasons to optimize them are, number one, we all exist because of customers. As simple as that. As folks that work at a business, to improve the experience, whatever that is, if it's a time-bound thing or revenue or net promoter score, so on and so forth, DevOps can help you innovate very quick at the speed of business. It can also help you support scale. So it marries business and agility in the infrastructure very closely, very intimately, where any weak links in the process are immediately brought out to people's attention. And then it helps you do agile deployments with built-in health checks. And then also helps you enable and enables improvement of your employee satisfaction and helps you retain resources, especially high impact resources.
Very good. Vamsi, thank you so much. I have 2 closing requests for everyone. Number one, if you are currently employed, I would request that, let's drink our own dog champagne. Take one actionable insight from this webinar and go and try a controlled experiment in your context to apply at least one of these metrics to achieve at least one of these outcomes within 30 days or less, right? Try one control experiment to move the needle on one leading indicator. If you are not currently, you don't have a gig and you're in transition, my heart goes out to you. I've been there. It's not a good place to be in a holiday season. Here's my ask to you. Take what you heard today, write a short post on LinkedIn, write a blog, and say, here are 5 things I learned, or here are 3 things I learned from this webinar. And here are 3 things that I would recommend you do in your context to improve business outcomes. Because the hiring managers are probably looking for people who are hungry to learn, who go out, invest time in learning new ideas, and then are able to apply the theory into real world practical actions. So that's my advice to you. If you're in transition, take what you've learned here, convert it into a short LinkedIn post, tag me, tag Vamsi, and we will like and share and comment, and we will try to use our network to get your profile as many hits as possible, and possibly help you build your brand so that when you get your next interview, you go your next interview and people look up your profile, they're impressed. And hopefully when you keep popping up in the feeds of people, maybe the hiring manager says, I need to go hire this person. All right. So those are 2 suggestions. I hope you found this useful. Stay safe, stay healthy during the holiday season. Thank you for spending time on Agile DevOps TFW. Until our next meetup, thank you, keep calm, and scrum on. Thank you, Vamsi.